Okay, let's graph again, rational functions. We're going to go from an equation to the graph. Now, this is the one that's a little bit more complicated. So first thing off, I'm going to draw it here, kind of tiny on the side. There's your X and your Y axis. This is also in your notes, but maybe this will clarify it a little bit. So the first step are the zeros. So number one is zeros are the x-intercepts, right? So that would be at x equals 1 and x equals 5. There's no bounce, there's no multiplicity going on there, okay? So I would plot that. So let's put that in there. Here's x equals 1. And there's x equals 5, somewhere out there like that. Okay, the next step, vertical asymptotes. So verticals occur when the denominator equals 0, which is not allowed. So x can never be equal to -1. So x cannot equal -1, and x cannot equal 7. Not equal to 7. Otherwise, you would have a undefined case down here. So let's put some vertical asymptotes in at -1. Okay, x equals -1, and then one at 7 over here. Again, this is not drawn to scale or anything. There's x equals 7 right there. Okay, third, number 3, that's 1, 2, 3. This is the horizontal asymptote. Okay, so the first thing we're going to look at, just let's analyze this already. This has a multiplicity of 1, so overall 2 degree on the numerator, 1, 1, so overall degree of 2 on the denominator. So the degree of numerator and denominator are equal to each other. So the horizontal asymptote would be the coefficient, which is what? What is the number that is there? If you see no number, it's not 0 again. 0 means nothing. That means there would be nothing there but vapor. All right, but there is something there. That number would be 1. But for quiz and tests, this is what we want to see. The limit, the formal definition, as x approaches infinity of your function, x minus 1 times x minus 5, all over x plus 1 times x minus 7, is equal to, so if you replace all the x's with an infinity, infinity minus 1, infinity minus 5, infinity plus 1, infinity minus 7, all of these numbers are so negligible, okay? They're so insignificant compared to infinity. So you could just get rid of all those tiny little adding and subtracting numbers, and you're going to end up with x times x, which is x squared, over x times x, which is x squared divided by x squared. Anything divided by itself equals a 1. Anything divided by itself. I don't care if it's a root 3 over root 3 or x to the -5 over x to the -5. Anything divided by itself equals 1. So yes, there is a horizontal asymptote at y equals 1. I'm going to draw that in there now. Y equals 1. So this is how we expect you to label everything. You got to label your zeros, your verticals, and your horizontals. Now for the so-called info wave. Okay, so we're going to do that down here. It'll take a little bit more room. Info wave, and I call it wave in parentheses or quotations because I don't like the wave. All you need are positives or negatives. So draw yourself a number line. Mark the zeros on there. So there's one at 1 and one at 5. So 1, 5. So I do zeros represented by a dot. Okay, and then the verticals, I put an X there because it's not allowed to be there. So you need to do something too to distinguish, put a dot or an X. So here's going to be one at -1. That's a -1 there. And then there's going to be one at 7 over here, like so. All right, so now you have all these different sections. This section, this section, this section, this section, this section. So 1, 2, 3, 4, 5 different sections there that we got to test. So I'm going to write your function. F of x is equal to x minus 1 to x minus 5 divided by x plus 1, x minus 7. And I'm going to check for each section here. So I'm going to pick a number here above anything from not the endpoint, anything above 7. I pick an easy number. Pick 10 if you want to. I don't care. Pick 8, pick 9, pick 10, pick 20. I just pick the easiest number I can think of. I'm going to pick 10. All right. It won't matter. You can pick any number up here. You should get the same exact result. All I care is positive or negative. Positive or negative. That's all I care. Each section. Okay. So I'm going to pick 10. If I pick 10, 10 minus 1 is a positive number. 10 minus 5 is a positive number. 10 plus 1 is positive, and 10 minus 7 is positive. Everything you have there is positive, so this section will be positive. All right, now I'm going to erase everything. Going to do it for the next section. Okay, because I'm lazy. I don't want to rewrite this 10 times. Okay, so a number between 5 and 7, say 6. All right, 6 minus 1, that's a positive number. 6 minus 5, positive number. 6 plus 1, positive. 6 minus 7, negative 1, so that's a negative. Overall, if you multiply 3 positives times a negative, you are going to get a negative number because there's an odd number of negatives. Okay? Try it with the real number if you don't believe me. Right? 6 minus 1, that would be 5. Times 1 divided by 7 times negative 1. Okay? Figure it out if you don't like what I'm doing. Okay, next one. Let's pick between 1 and 5. I don't know, 2, 3, 4. What do you want? Let's try 2. 2. 2 minus 1, positive. 2 minus 5, negative. 2 plus 1, positive. 2 minus 7, negative. Overall, multiplying 2 negatives and 2 positives, you're going to get a positive number here. Okay, next. Next, between negative 1 and positive 1, I'm going to pick 0. That's a good number, easy number in between there. 0 minus 1, negative. 0 minus 5, negative. 0 plus 1, positive. 0 minus 7, negative. 1, 2, 3 negatives. 3 negatives times 1 positive is going to give you a negative number there. Okay, last section. Okay, any number below negative 1, anything in this region here. I don't care if you pick negative 200. Let's do it, negative 200. Negative 200 minus 1 is a negative 201. Negative 200 minus 5 is also negative. Negative 200 plus 1, still negative, and negative 200 minus 7, still negative. You could have picked negative 2. You could have picked negative 10. You could have picked negative 5. Plunk the number into X if you don't believe me. Pick all those numbers down there and see if you come up with a 1, 2, 3, 4, an even number. A negative times a negative times a negative times a negative would give you a positive number. Check it out if you don't believe me. All right. So now we've got this number line, this info wave. So we're going to read everything. Remember, we worked it out from this direction. So we're going to work from left to right. Right to left, excuse me. So first section here, everything, let's zoom out so you can see everything. Okay, we're doing this section first section. Okay, so that represents the vertical asymptote right there. at x equals 7, and everything to positive infinity there is going to be overall positive. So you've got this asymptote, this horizontal going here, would actually keep going, right? Okay, so which section would be more positive? This one or this one? This one up here, right? That's positive because of that. So you should know at the end behavior, we're talking about horizontal asymptote. Your function should be following it. Since this is the more negative section, we're going to go up here. There's your function. And then can it cross the vertical? No. It's got nowhere to go up, but right, positive. It's more positive, so it's going to go up, not down. All right, next, between this 0 and 7, it's going to be negative. So it's definitely touching the x-axis there. And because it's negative, it's going to go downward. And it will never cross the vertical, remember? Okay, next section, between these two zeros here, it's going to be positive. That means it's going to go up. But remember, eventually it's going to come back down because it's going to cross over at the 0 here, okay? So it's going to do something like that. Right? Negative, it would have gone like that. But it's not. It's positive. Right? So, I mean, eventually it's going to come back down to that 0 there because it's going to cross or touch at that x-axis point right there. Okay, there's that. Okay, now between these two, between this 0 and this vertical, between this 0 and this vertical, it's going to go down because it's negative. And it will never cross the vertical, just like here. And the last part, it is positive again. So you've got two sections, this section and this section. And again, a horizontal is going to determine the end behavior. So which one is more positive? I would say this section over here. So the very end is going to follow your horizontal asymptote. And then it cannot cross the vertical. So it's going to go up there. All right. There we go. And there's your rational graph right there. It looks like this. Okay. Let's do one more. This one's a little bit more detailed. Try it out. Okay. So again, here is our function. This one, we have some bounce going on in there. Okay. So first of all, let's draw an x and a y axis. Okay. First step, x-intercepts. So at x-intercepts at x equals 1 and x equals -5. And that will have a bounce. Okay. So let's draw them in. Go for it. So at 1 and at -5. Okay. Secondly, verticals, vertical asymptote where it can never be equal to 0 in the denominator. So if that's 0 times anything, that would make the whole thing 0. So none of these can be 0. Verticals at x equals 0 and x equals 4. And that will have a vertical asymptote bounce there. Bounce, so to speak, right? A multiplicity of 2. So we'll look at that in a second. Let's draw our verticals in at 0. Now, when you do this, be careful because a lot of people draw it right on top of their y-axis there, x equals 0, and then you can't see it. So just draw, and then you make mistakes, like people are crossing over it because they can't see it. I'm just saying, I see this all the time. Okay, so if you label it correctly, right, x equals 0, just draw it real close next to it so you can see that it's there. People do that all the time. Technically, you're correct, but then they make the mistake and they don't see it because it's right on top of the y-axis, okay? All right, number 3, horizontal. Let's just look at it. Degree, overall degree of numerator, 1, 2, 3. Overall degree of denominator, 1, 2, 3. So they both have an equal degree, which means it should just be the coefficient. But we have to do it this way. You will have to absolutely describe it like this. The limit as x approaches infinity of 3 times x of your function, x plus 5 squared all over x times x minus 4 squared. Okay, this is what we want to see right here. Okay, so as x approaches infinity, so you put in infinity for all your x's. When you do that, all of these tiny numbers here become insignificant. So infinity minus, so I'm not crossing out the whole factor, I'm just crossing out the -1 there. Infinity, 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 infinity. Who cares about infinity minus 1? That's just meaningless, okay? So this becomes 3 times x squared, which is 3x cubed. And this becomes x times x squared, which is x cubed. The x cubed over x cubed, remember, any number divided by itself equals 1. So 3 times 1 equals 3. So you will have a horizontal asymptote somewhere here at y equals 3. All right, so now we're doing the last piece, which is the information wave. So I'm going to draw the number line here, I guess. I'll do it like that. And this is the number 4, the info wave. That's a pretty bad F there, sorry. Okay, so what you need to do is label your zeros and your verticals on this number line. All right, so there's a 0 at 1. Make it a dot like a 0. There's a 0 at -5. Make it a dot at -5. There is a vertical at 0. So make an X for verticals because not allowed. X means it's forbidden to cross it. And there is a vertical at 4, which I never wrote in there, did I? Let's do that one too. I did not do the 4 on here either. X equals 4. X equals 4, right? Just neglected that there, okay? So let's do the vertical here at 4. That's 0. All right, good. So at 0 and at 4, 0, 4, 0, 4. Good. 1, -5. 1, -5, 1, -5. Okay, and these are in order, right? -5, 0, 1, 4, -5, 0, 1, 4. Okay, good. So now you have 1, 2, 3, 4, 5 sections, right? Between here and here, here and here, here and here, here and here, here and here. So we are going to test your function. So here we go. We're going to test it for positive or negative. Okay, so I'm going to write your function down. Going to write it down. G of x is equal to 3 times x minus 1 times x plus 5 squared all over x times x minus 4 squared. Okay, so let's just look at this right quickly here. This includes, when you test it, the number that's in front there. This number that you have is always going to be positive. Okay, I want you to also look at this. Whenever you have a squared, if you have any number in here, a positive squared will be positive. And what about a negative? A negative times a negative. A negative squared will always be positive in this part right here. Same for this. Anything, a positive squared or a negative squared will always be positive. Okay, so we're just going to have to check these two with each section there. Okay, in combination with all of this. All right, so this section here, any number above 4, anything. Try 5, try 6, try 7, try 10, try 100, whatever, any number in this section. I'm going to pick 5. So always positive. 5 minus 1 would be positive. This is always positive. 5 itself is positive, and this will always be positive. So all positive numbers multiplied together will be positive. All right. Again, those 3 don't change. They're always going to be positive. So now I'm going to pick a number between 1 and 4. I'm going to pick 3 or 2 or 0.5. Doesn't matter. Pick a number. Check it out. 3 will always be positive. Let's pick 2. 2 minus 1, positive. And 2 itself is positive. So we have, again, all positive numbers. So it will be positive here. Okay. Next, a number between 0 and 1. I'm going to pick 1/2. 1/2 minus 1 is negative. Always positive. 1/2 itself is positive, and this is always positive. So we have one negative overall of positive times a negative times a positive times a positive times a positive is a negative. Next. Remember, we're always going in this direction. Okay. Next, between 0 and -5, I don't know, -1, -2, -3, -4, -0.75, doesn't matter. I'm going to pick -1. All right. -1 minus 1, that's negative. And -1 itself is negative. All the rest of these are always positive. Right, check it if you don't believe me. -1 plus 5 would be 4. 4 times 4 is positive. Okay. So 2 negatives multiplied out become a positive. And the last part here, let's try any number below -5, like let's say -10, -11, -6, -6.5, -6.7, -7.8, whatever number you pick should give you the same result. And if you don't believe it, actually put that number in here into the function and see what you get. But all that matters is positive or negative. All right, so -7, let's say -7 minus 1, negative, and -7 itself, negative. 2 negatives become positive. All right. So I'm going to just put this all together now. Let's look at this. Let's just kind of look at this to make sense out of it. Look at what's going on around this vertical asymptote. Both sides of your graph are going in the same kind of direction. They're both positive. Does that make sense with your vertical asymptote here with this situation going on? Oh, what is that? That's called a vertical asymptote bounce. Okay? How about over here and here around this 0? Does that make sense with your function? A 0 bounce. Okay? All right, so let's put this together. All right, so the first one, from this horizontal onwards, it's going to be positive. So again, I did not draw this very far because I had this writing here, right? But this horizontal would just keep going out like this. So you have a section here going forever or here going forever. Okay? Above the horizontal or below the horizontal, what do you think? Probably above it, right? Because it's positive. What else do you know? A horizontal asymptote defines the end behavior. The end, the right end of your graph should be following your horizontal asymptote. And then after that, okay, You can't do much but go upwards because you cannot cross that vertical asymptote right there. Okay? So following the end behavior and then going up because you can't cross it. Can't cross that vertical. Next, between this 0 and that vertical, it's going upward, positive. So here's your 0, here's your, right? In between these two, the 0 and the vertical is right here. It's going to go up. And can you cross a horizontal in the middle part of your graph? Yes. The horizontal is just about the ends. You can cross it in the middle. Can you cross the vertical? No. What is that called when both ends of the graph are sandwiching the vertical asymptote like that? That's that vertical bounce going on. Okay, they're both going upwards there. Both in the same direction is a bounce. Both up or both down. Okay, and then between this 0, this 0 and this vertical, so there's a 0, there's a vertical, it's negative, so it's going to go downward. Okay, and then you have between this 0 and this vertical, this 0, this vertical, that's what that represents, is going positive. So going upwards. Never, you can cross this in the middle, but you can never cross the verticals. And then the last but not least, you have this situation right here. So remember, your end behavior is determined by your horizontal asymptote. So somewhere out here, it's going to be up here. And guess what? You just connect it like that. And what is that showing? That is showing this bounce situation there, right? Boing. Okay, there you go. Finished. There's your rational function right there. Thank you very much.